Welcome to Artificiality, where minds meet machines. We founded Artificiality to help people make sense of artificial intelligence. Every week, we publish essays, podcasts, and research to help you be smarter about AI. Please check out all of Artificiality at www.artificiality.world. In this episode, we speak with cognitive neuroscientist Stephen Fleming about theories of consciousness and how they relate to artificial intelligence. We discuss key concepts like global workspace theory, higher order theories, computational functionalism, and how neuroscience research on consciousness in humans can inform our understanding of whether machines may ever achieve consciousness. In particular, we talk with Steve about a recent research paper, Consciousness in Artificial Intelligence, which he co-authored with Patrick Butlin, Robert Long, Yoshua Bengio, and several others. Steve provides an overview of different perspectives from philosophy and psychology on what mechanisms may give rise to consciousness. He explains global and local theories, the idea of a higher-order system monitoring lower-level representations, and similarities and differences between human and machine intelligence. The conversation explores current limitations on neuroscience for studying consciousness empirically and opportunities for interdisciplinary collaboration between neuroscientists and AI researchers. Stephen Fleming is professor of cognitive neuroscience at the Department of Experimental Psychology, University College London. Steve's work aims to understand the mechanisms supporting human subjective experience and metacognition by employing a combination of psychophysics, brain imaging, and computational modeling. He is the author of Know Thyself, a book on the science of metacognition, about which we interviewed him on Artificiality in December of 2021. Thanks again for joining us on the podcast. We're excited to talk to you again today. Perhaps, can you start off by talking about what inspired you and your co-authors to write this research report now?
Sure. Yeah, well, it's a pleasure to be here. And this paper, really, it was the brainchild of Rob Long and Patrick Butlin, who are two philosophers who are really at this intersection of artificial intelligence and philosophy of mind. And it really came out of a workshop that the two of them put together in Oxford, I guess 2 years ago now, which was designed as a way to start having a conversation between psychologists, neuroscientists, philosophers, and people working in the field of artificial intelligence. And it's rare to, even though these fields are all allied in their interests in mind and the brain and what it means to have intelligent behavior, it's rare that you get that kind of mix of people in the same room. So that was really interesting and exciting. And really, it was it was a blank slate, essentially. It was a one-day meeting aimed at trying to reduce down the space of the conversation around whether we could ever make some kind of academic statement about the possibility of artificial consciousness. So this is clearly something that's been talked about so often, and it's a regular favorite of sci-fi writers and so on. But given the progress in the neuroscience of consciousness over the past 2 or 3 decades, the hope in that initial meeting was that could we bring to bear some of that understanding that we're getting from experiments on the human brain and try and use that as a solid platform on which to build some inference as to whether artificial systems are conscious. So it's really driven by Patrick and Rob, and they had a difficult task because essentially their task over the subsequent 2 years was herding various stripes of cats in various different fields with various different languages, ways of talking, jargon, and so on, to bring them together to, I think, make a really interesting statement about what might be possible going forward for pronouncing on the consciousness of artificial systems. So I view this as very much it's almost like an exercise in meta science. It's not saying we are able to say today whether a system is conscious or not. I think we're very far away from being able to do that. But it's, in a sense, like a recipe for how one might be able to do that. as the theories of consciousness progress on the neuroscience side, and as we get ever more impressive AI on the artificial system side.
One of the, it would be quite an achievement just to corral those striped cats of the human side, because there's so many different variations and breeds of theories of consciousness, which we'll get to in a minute, because I think that's really helpful to give listeners a bit of an overview of that. But given that half of this is AI and half is human, and the AI side is sort of has this tricky problem of how do you can't just ask an AI whether it's conscious, because that's an obvious place that could be deception or what have you. Can you talk a little bit about these sort of two kind of core grounded, it's almost the boundaries that you guys put around this paper of computational functionalism and being really theory heavy, not being so empirical, and why those two are so important to the shape of the paper and where you end up taking the scholarship and the academic statement, as you said.
There's quite a lot to unpack there. So I guess the first thing to say, and which is, I think, an important first step, is to try and demarcate what we mean by consciousness and what we mean by intelligence. And these are not the same thing. The notion is that you can have intelligent behavior without anything that it is like to experience that. So this is the hard problem of consciousness. Why should any kind of functions being performed by a physical system like the brain come along with any kind of subjective experience? And vice versa, you might have a biological brain that's doing very little, but might have an experience of doing very little. So there seems to be a distinction there, a fairly broad one, between what psychologists would call intelligent behavior and what philosophers of mind would call phenomenal experience or subjective experience.
So you could have some sort of agent using that's learning through reinforcement learning, which isn't shows intelligent behavior but has no subjective experience. And you could have some sort of stimulus response behavior that actually does have some sort of subjective experience. We just don't know how to measure that or how to understand that.
Yeah, exactly. And I think, there's existence proof of those two cases in humans. So you can have, very low-level reflexes which seem to unfold without any kind of subjective experience involved. And so there's, I guess, a kind of running assumption going through the science of consciousness that it is possible to contrast conditions where you have some kind of neural processing going on, and in one case you're conscious of that thing, and in another case you're not. And that's really served as the kind of bedrock of the experimental method in the science of consciousness. And that then leads on to this problem in AI, as you said just beforehand, about this gaming problem, that assuming that intelligent behavior and consciousness can come apart, then you might end up in a situation where, because you've trained a system to do amazing things like mimic human language, if you ask ChatGPT, are you conscious, then it could come back with a response, a quite eloquent response. But whether that has any bearing on the philosophical notion of subjective experience seems quite shaky and dubious. And this has been the basis, I guess, of all these controversies recently, like Blake Lemoine claiming that the large language model was conscious, and essentially the linguistic fluency, because we're so used to associating that with conscious experience in humans, we're sucked in by that. And so there's this kind of grey area. And some people have said, well, no, we should take that seriously. We should actually take reports of saying that a system is conscious as seriously as perhaps we take them in humans. Susan Snyder's made this point that if we were somehow able to isolate the large language model from any knowledge of, say, the neuroscience of consciousness, the philosophy of mind literature, and it spontaneously said, hang on,
what's going on here?
Having this strange, what's going on? I'm having a strange experience.
I don't know what to name it, though, because I haven't learned the word yet. What's the word?
Exactly. Yeah. So I'm somewhat, I thought that was an intriguing idea. I'm not personally fully convinced because I still feel as though you're resting on an architecture there that is just so unlike the architecture that we assume is involved in phenomenal experience in humans. But I think it was an interesting idea in terms of trying to get an indicator that might somehow be immune from this gaming problem. But the approach that Patrick and Rob and the other authors in this report took was somewhat different. It was essentially to say behavior is not going to be enough here because of this problem of being able to game it. And instead, we need to take a theory-heavy approach. We need to essentially take what we know about these markers of consciousness from theories that are being developed on the human side and ask, do they have similar, do artificial systems exhibit similar markers? And that then leads you on to a broad domain of way of setting the way of trying to set up the problem of consciousness known as computational functionalism. So this is the idea that the any system that implements the relevant kind of computational function is conscious. So if we were to find out what that function is in the human brain, then we could abstract away from the substrate of the human brain and say if we could discover similar computations in another system, whether that's a neuronal system, a silicon-based system, or anything else that's enabling a similar type of computation, then it would also qualify as being conscious. And I think sometimes that idea of computational functionalism seems a little odd when you first think about it, because it means that somehow these mental features are floating free of, well, they're certainly floating free of biological brains in that characterization. But it is actually quite a common assumption in psychology and other branches of computational neuroscience that the relevant level of analysis for understanding, say, memory or decision-making or perception and so on is not necessarily the exact neurons that are doing the job. It's the general processing pipeline, if you like, that gives you the function of being able to make a decision. And the idea in this paper is that if we endorse that, then that gets us away. It gets us out of the starting blocks, because we can then say, well, we can look at whether there are similar functions that have been posed to support consciousness in the human brain and ask whether they might have analogs in artificial systems.
Right. So just so I understand that better. So instead of looking at the system at the level of, say, the chemistry or the physics or even the basic sort of structure, you're looking at the next level up, if you like. You're looking at how information or how something is represented and being able to sort of and build the theories around that particular level of the system.
Yeah, that's exactly it. And I think that, it is important to recognize that this is an assumption of this paper. So if you disagree with that assumption, if you think that a proper explanation of consciousness in humans and other animals is going to require something about biology, about the wetware of the brain, then the kind of arguments we advance in the Butlin paper are not going to convince you, because you're going to essentially deny that first assumption.
Right. So if you thought that consciousness is a function of being alive, then you're going to disagree.
That's exactly it. And there's also an interesting intermediate position, which I personally find attractive, which is that you might find that when you actually implement all the physical requirements for the kind of computation that supports, say, consciousness or other aspects of the human mind, then you might end up building something that looks quite like a biological embodied brain when you're finished. So at the moment, I think a lot of the discussion around, say, theories of consciousness is relatively abstract. There's, I guess, a broad assumption in a lot of neuro AI that you can essentially port across from neurons to nodes in a neural network. And you can essentially kind of go back and forth between those levels of description. But a single neuron is doing amazingly delicate computation. You know, it's got thousands of dendritic inputs that are all very sensitive to local context and so on. And so there's an argument that's made, and Daniel Dennett has made this point as well, that it might not be the case that life or biology are somehow kind of, there's something intrinsic about them that supports consciousness, but it might be that when you cash out all the computations going on that we don't fully understand yet, that you end up with a quotes artificial system that actually looks pretty biological. So I think that's a really interesting intermediate position to consider.
Can you describe some examples of these things one layer up? You know, these functions that we might be able to evaluate and test for. Just give some examples so we can put some tangible ideas in the listener's mind.
Sure, yeah. So I guess one prominent example in the area of consciousness research is the notion of global broadcast. So there's a broad division between local and global theories of consciousness. So a local theory of consciousness would say that your consciousness of a sensory property like a visual experience can be supported by information processing going on within cortex that's dedicated to that sensory modality. So local to that area of the brain. Whereas a global theory would say that any processing that goes on that's restricted to that local area of cortex is not conscious. It's being processed unconsciously, and that to become conscious of it, you need to somehow put that information in a more global form across the rest of the brain. And then global theories differ in terms of how that is cashed out. So a global workspace theory says that you put it into some common workspace. A higher order theory says that you somehow monitor the primary sensory representation in a way that recruits these global resources. So the kinds of, to take global workspace as an example, the kind of computation that we're referring to here is, imagine you have some modality-specific neural network, and that's how a lot of people think the visual system might work, for instance. So you've got some kind of input coming in, going to primary visual cortex, and then via recurrent interactions with other visual areas, that's elaborated and becomes more and more categorized into faces and other objects and so on. But that's all modality specific. That's all dedicated, if you like, to solving the problem of vision. And then the global workspace theory would say, once you're done, essentially, with that kind of domain-specific processing, that representation of, say, the cat you're looking at gets broadcast into a global workspace that then is available for language, for other types of flexible action, for memory, for doing anything you like with that representation, essentially. And so, yeah, go on.
I was going to say, I was just going to try an example. So if I'm walking down the street and I see a golden retriever, and that happens just as seeing it, and it's just a visual thing that's local. But when it cues memories of the golden retrievers I used to have, and Helen likes to laugh at me that I get a little tear in my eye, and I start anticipating that we might actually get another golden retriever, and I start remembering all of the fuzziness of digging my hands into their fur. That's more global?
Yes, with one caveat, which would be that a global theory would say that even before you get to the retrieving the memories, the emotional response, even before that, just being conscious of the dog requires the global broadcast.
Okay. It's very helpful. Thank you. It also gives something for Helen to laugh at me about for the rest of today.
So he's not, so it's less about being conscious of, so below that, there's something going on, like it's picking up the edge of an eye or what have you, or something that says it's a dog because it's fuzzy. But then that once it's the dog that is broadcast to the global workspace, it competes for other things, which has got to have something to do in there with attention. And then that becomes available to all of the other connections.
Yeah, that's essentially the picture. So the theory I'm describing here was originally proposed by the psychologist Bernie Bars back in the 80s as a kind of cognitive model of how consciousness might work. And then the neuroscientist Stanislas Dehaene picked this up in the late 90s, early 2000s, and made this into a neuroscientific theory. So essentially mapped Bernie Bars's global workspace, which Bars characterized as a blackboard or theater, where kind of something goes into something central. And Dehaene proposed that the association areas of the cortex, parietal and prefrontal regions, are supporting this global workspace. Now, what the workspace is, what it kind of means, like what it's doing, this has always, I think, been left somewhat vague. Like, even though Stan Dehaene has, these beautiful experiments that show that when you contrast the difference between being conscious of a stimulus and a stimulus being invisible, you get what they refer to as ignition of these workspace-like regions. It's always been quite hard to pin down, like, what exactly are those regions doing computationally? And I think this is partly because we're constrained by other branches of neuroscience. Like, people don't really know what the prefrontal cortex is doing in broad strokes. There's lots of data, but until we have a more solid picture of what these higher order regions of the human brain are doing, that's always going to remain somewhat vague. And so hopefully you can then see, well, that poses constraints on how vague or precise we can be about the connection over to AI. Because if we have to remain vague about what global broadcast means, which I think we do at the moment, then it's going to be hard to know whether you've built an artificial system that really meets that constraint.
And at the moment, from what I understand about the way that the AI researchers are taking this is more to having almost a traffic cop, something that's directing traffic and making decisions at a higher level, which almost strikes me as a little bit of a combination between global workspace and higher order theories. It's a little bit of a hybrid of the two, where there's higher level representations, but there's also this broadcast, this competition for sharing the information and directing the information across to other parts of the network.
Yeah, I mean, this is where I would need to defer to the AI colleagues on that paper, and I'm, this is more me looking on from the outside at those what they're developing. But my understanding is that there are aspects of some models that are being developed, for instance, by Yoshua Bengio and others, where there's this kind of shared latent space. There's something that looks a bit like a modality independent representation that is then kind of farmed out to different consumer systems. And there's been some interesting work from colleagues in the field. Ryota Kanai is one person who's doing a lot of work on both AI, but also he's worked previously in the neuroscience of consciousness. And he's written a couple of papers trying to essentially analyze AI architectures from the point of view of saying, does it or does it not have what we would construe as a global workspace? And I think there are some indications that perhaps it doesn't have all the features, but the general sense among the people writing this paper was that it would be, if someone really wanted to do it, it would not be hard to do at all.
So what about the higher order theories and what they bring in, and particularly around some of the stuff that you specialize in metacognition? We sort of left off our last podcast almost wanting to have this part of the conversation, which we are now more ready for.
Yeah, absolutely. Yeah, I mean, so higher order theories is another way of thinking about global theories of consciousness. Like what is the global resource doing? And the starting point here is in philosophy of mind, and philosophers have proposed for a number of years that perhaps what makes something conscious is some form of self-monitoring, some form of meta-representation. So essentially the system, if you have what philosophers call a first-order representation, so when something is perhaps just represented in that visual system we were just talking about, then that would remain unconscious until a higher order part of the brain meta represents that. Essentially, there's some kind of internal knowledge or thought about that first order representation. And so that general idea has been recently developed in more computational terms by Hak-Quan Lau and some work we've been doing in our lab as well. And the idea here is that what might make something conscious is essentially a higher order system monitoring how reliable our first order representations are. So this then draws a strong connection with how confident we are in different percepts. So the idea is that if we are conscious of something, that's when we're essentially telling ourselves we are confident we are seeing this or hearing this. We're not doing it on an explicit level, but we're doing it on a more implicit level. It's like the brain tagging the sensory experiences as trustworthy. So there's an interesting backstory about why you might want to do this, which I think is quite compelling, which is also lends it a more evolutionary explanation. So like, why would consciousness evolve in the first place? And so the idea here is that if you have a system that's complex enough, that starts doing internal simulation, that starts being able to imagine the future, just like we can, then you need some higher order system to keep track of what's real and what's just being imagined. Because if you didn't have that higher order system, then you'd go around acting on all your imaginations, and that wouldn't be very, you'd probably rapidly come unstuck if you started
the evolutionary argument.
Exactly. So, and one thing that some people in AI have pointed out is that, that sounds really similar to what a generative adversarial network is doing, essentially trying to discriminate, is it A or B? Am I getting tricked by my own imagination?
Didn't Hak-Quan Lau have some link to that as well? He talks about generative models.
Yeah, exactly. So Sam Gershman, the computational neuroscientist, wrote a paper on this, and Hak-Quan also then talked in similar terms that perhaps that one link into AI is that, essentially what the human brain might have is some, in broad strokes, discriminator trying to tell whether you're perceiving or imagining. And when that discriminator says you're perceiving, then that is what we call conscious experience. That is, it gives us this belief, this incontrovertible belief that there's an external reality out there. And so I think it has an interesting kind of illusionist flavor to it, because it says that, what that's explaining is not necessarily the intrinsic nature of conscious experience, but it's explaining it's giving a reason for why we as humans go around saying there's this amazing world out there that is like, we have this subjective experience. And the idea from these variants of higher order theory is that the reason we say we have this subjective experience, the reason why we think consciousness exists, and it is because we have this algorithm running behind the scenes that's trying to tease apart whether what is going on in our sensory cortex is essentially being driven from the outside or being driven from the inside as imagination.
So that sounds like there's quite a lot of crossover with predictive processing.
Absolutely.
In terms of like almost like predictive processing sort of sits underneath that as a. So, what are the most compelling in your mind empirical evidence for higher order as consciousness as opposed to just simply perceiving?
Yeah, well, just to pick up on the predictive processing angle, so this general approach doesn't have to sit on top of predictive processing, but the approach we've been taking in our lab does make that link explicit. So we've been trying to develop a version of this story that essentially extends out regular predictive processing architectures to include a higher order monitor of whether the predictive architecture is essentially being run in a bottom up or top down manner. It's trying to essentially figure out that. And yeah, we've been finding that to be quite profitable because we've used that as a way of developing hypotheses about empirical data. And this is with a postdoc in my group, Nadina Dijkstra, where we're bringing people into the lab and we're giving them, essentially putting them in minimal situations where we ask them to imagine simple stimuli. And then sometimes we fade in the real stimulus at the same time that we're asking them to imagine that stimulus. And that provides us with a really rich psychophysical testbed where we can probe people on this higher order question. We can actually ask them on that trial, did you see something real or were you just imagining it? And so we're now setting up a bunch of experiments using brain imaging as well, where we're hoping to use that kind of setup to probe brain activation that we think is involved in this higher order reality monitoring decision. And so I think that will get interesting data on the potential neural basis for these higher order mechanisms. But then in terms of what you were asking just now about, what's the evidence for these higher order states contributing to conscious experience? I think that there isn't much, actually. It's early days. When you look at, there was a nice meta-analysis done by Liab Mudrick's group a few months ago where they essentially looked into the literature for experiments that had claimed to test particular theories. And there were plenty of papers testing global workspace theory, but very few testing higher order theory. So I think one line of evidence is that if you have damage to the prefrontal areas of the brain, then you often screw up implicit metacognition. You essentially impair the ability to assign confidence to your perception. Now, it's very hard to tie that directly to changes in conscious experience because you have this kind of catch-22 because you don't know, the patient cannot tell you if their conscious experience has changed, if they are unable to monitor the fact their conscious experience might have changed. So you're essentially left with these indirect methods, psychophysical methods. And there's been very, very few studies, maybe 2 studies that I can think of, that have applied systematic methods within psychophysics and metacognition to really probe whether there are subtle higher order changes following prefrontal lesions. And I think based on that very small number of studies, it's encouraging. There are reasons to believe that these higher order states are contributing to not just to the ability to report, but also essentially the force of your experience. And there are ongoing experiments that we and others are doing to try and test exactly this.
Hi, it's Dave with just a brief interruption. If you're enjoying our podcast, we'd love it if you'd share it with someone who you think might enjoy it too. And check out everything that Artificiality has to offer at artificiality.world. Reach out anytime. We'd love to hear from you. back to the interview.
I know he's itching to ask a question.
I'm going off in a different direction, which is, as you talk about sort of the category, the things we know about global workspace and higher order, and what seems like sort of an immeasurable amount that we still don't yet know, right? There's a lot.
Absolutely.
That and as you think about collaborating with AI scientists, as you have in this paper, one of the things that we've seen in the AI industry is they pick a target and say, we need to figure out whether this AI can be, as smart as a doctor, or whatever way they want to phrase that. And so they look at it and they say, well, there's one way we know how to measure it is whether it can pass the MCAT. And it misses this other vast, immeasurable thing that says what makes a really good physician. And there's so many different things, but they're actually untestable, or there's some things that we probably don't really even understand about the interpersonal relations or something like that.
Or it's context dependent.
Or it's context dependent. But in your world, there's plenty where you're saying, as you're describing this, you're like, well, the global works, we don't really understand how it's working yet, or this part of it we don't understand. How do you think about that handoff where you're saying, kind of, this is what we do know about consciousness from neuroscience, and then seeing, you can see how the AI folks would then race towards those few things that you're able to describe and have a measurable test, and they're going to go, see, we can do those things. Now we're conscious, and you're like, whoa, wait a second. There's this huge other bit over here that
the kind of necessary but not sufficient.
Yes, yeah. I'm just curious how you think about that handoff.
Yeah, no, it's a great question. I mean, I think in general, I feel that there's a lot of uncertainties about the indicators that were proposed in that paper. And I really come back to that comment I made before about, in a sense, I feel like this was mainly an exercise in meta science, how to do this kind of science, how to do this kind of interdisciplinary work. And to get the project off the ground, we engaged in this survey of possible indicators. And I think it's going to be an iterative process now, right? So these are provisional models of component processes. And one thing I didn't say before is that, you can combine different aspects of different theories. So people have suggested, for instance, that Hak-Quan Lau himself in his book, laying out his version of higher order theory, suggests that this process of essentially monitoring how trustworthy your perceptual representations are could be the key switch, if you like, that gets things into a global workspace. So the two theories are not at odds with each other. They're at odds in what is primary for enabling conscious experience. But you probably are going to need elements of lots of different of many of these ideas in a final working model. Biology is messy. It's not going to be that one person is going to come along and say, I've solved it, right? So that, and there's also, perhaps we want to get into this, I don't know, but I think that's also what I've got some misgivings about these recent adversarial collaborations, which I've also been part of, because they essentially set up this winner-loser competition where it's almost as if one theory is out there and all we have to do is cross out the ones that are going to lose, and then we'll end up with the final one. Now, I think it might be that one day we'll be in a position to do something like that. In the 1910s, the experiments that were done to try and contrast Newtonian physics with general relativity were of that flavor, that, they were comprehensive theories. They disagreed on a precise metric, and they could be tested against each other. But I think we're a very long way away from that in the neuroscience of consciousness. We have provisional models, component processes. Alone, they are not going to be sufficient. And essentially then we have to recognize that the bridge over to AI is going to be an iterative one. And one really interesting thing that kind of came out of these conversations with AI of people doing research on that side of things is that a lot of the messages that were coming back were kind of saying, we recognize this is somewhat vague, but you do need to realize that if you kind of made this a little bit more precise, we could probably code it up tomorrow. And everyone was like, oh, okay.
Hey, that sounds like a good idea.
yeah. But in a way, like the response, and I think the right response was not, oh God, we're going to build a conscious robot tomorrow. It was, yeah, okay, well, that puts pressure back on us to realize that our theories are probably much too immature to be engaging in that kind of exercise.
But you describe this over a history, different people over time and the development of these theories. And I'm struck by the work that you're doing in your lab right now. Am I imagining something? We'll just stick with the dog. Am I imagining a dog, or am I actually sensing a dog? That's one of those things that from the outside one might think is a pretty foundational difference to understand. But we're still in a state in neuroscience where we're discovering something that from the outside people would say, we don't know how to determine that yet, right? But it's because there's so many like groundbreaking things that you're working on in your field that would be sort of basic, necessary, for AI, right? Is the AI actually imagining it, or is it sensing it, right? That's actually a pretty good one right now to understand for generative AI, to understand whether it's what it's the state of its consciousness is.
Yeah, well, I imagine things all the time, and I'm not conscious. It's called dreaming.
Yeah, but it's an important thing that you're in your field. You're still working on some things that are really quite foundational. It sort of makes me think this arc of us understanding our own consciousness well enough to be able to define it so that the AI folks can actually code it might be quite a ways off, much farther away than many people in the AI space will say, because they're just thinking, well, how long is it going to take me to write this code versus I don't even know what code I'm going to even try and write yet.
Right. Yeah, absolutely. I mean, I guess there's lots to say about that. I mean, one thing is that the technologies we have for non-invasively imaging the human brain are still in relative infancy, and they're improving every day. I mean, functional MRI, so the ability to use MRI to essentially take fairly rapid snapshots of brain activity, only came to be widespread in the late 90s. So we're talking just over 20 years ago. And even though techniques like EEG were available before that, they have fairly coarse spatial resolution. And I think, the difficulty with consciousness is that you need the human in the loop to validate your theories and ideas. So if you want to know, say, how the hypothalamus works to control, say, breathing, you're probably much better off going to a mouse model and using single neuron recordings to precisely dissect that circuit. And people do, and they're doing beautiful work. But that strategy is not going to cut it for consciousness, because you need to keep the human in the loop. So we should absolutely be collaborating with people doing animal neuroscience to use the same paradigms, the same tools, the same essentially to compare and contrast the data we get from different kinds of recording modalities. But you're not going to get away from the fact you're going to have humans as the only people, as the only species we know who can reliably validate reports of what they're conscious of and not conscious of, to compare that against data from brain imaging. And so I think that's one of the reasons that we're where we are as a field at the moment, is essentially that it feels like quite early days because there's limitations on the technology, for one, but there's also kind of conceptual unclarity that needs to still be refined. This word consciousness is not very well defined. It doesn't stop us doing interesting experiments on it, but as the science progresses, then it's going to need to become more and more precise. And I think that people starting to develop computational models of what we mean by conscious awareness will hopefully help refine that. But all of that is quite early days. And so I think that, the being able to incrementally update the theories as those kind of data start coming in is clearly a major project for the science of consciousness. And I reckon that what will happen is that iterative project is going to take a long time, and hopefully there will be the continued conversation with AI researchers as well, like that was started with this paper. But I think that the research on the AI side is going to just accelerate away from that slower science. And so you're going to end up with this mismatch between our understanding of consciousness in humans, which is hopefully going to continue to progress, and the apparent consciousness the general public will start to attribute to these artificial systems. So we're going to be, I think, we're in quite soon in a place of quite strong mismatch.
Yeah, let's go into that a little bit more, because it seems very important. And part of it is what we notice already is a lot of confusion and conflation between consciousness, intelligence, sentience, the morality of suffering. There's so many different parts that people have trouble pulling apart. That seems to me part of the issue of public engagement with machines and the sense of whether they're conscious. But I'm really curious how you've sort of come to see that as an issue.
Yeah, I mean, I think that it really goes back to what we talked about at the start, which is that we have such strong priors when it comes to apparently intelligent behavior. So when we see a system that has high facility with language, like GPT-4, then it seems almost irresistible to start attributing some kind of mentality behind that language. And I think clearly these systems are improving in their mimicry of various aspects of human mental function every day. And so people are going to intuitively start assuming that there is something more behind them. Now, as we've just been talking about, I don't want to give the impression that that is a wrong assumption. It could well end up being a right assumption at some point in the future. I think probably not now, given the work we did in that paper. I think there was general consensus that current transformer architectures don't meet, or they hardly meet any of the criteria that were laid out in that paper for conscious experience. So I think the general consensus there was that they are, in a sense, mimicking that side of things. But if a system is going to seem lifelike, hold conversations, we increasingly use it for advice, assistance, even therapy, friendship, then I think we're going to end up quite rapidly in a position where we're going to be a bit like the kids watching the Pixar movie and attributing reality to these characters. And perhaps a lot of that will be benign. The fact that, my daughter thinks her Minnie Mouse is real. Yeah, that's fine, right? That's like, it's nice to have that. And as long as there's no, I guess, downsides to that, then, perhaps that's a world we can envisage. But I think one real danger there is that if people start investing emotional significance into relationships with seemingly conscious AI because they think they're conscious, then we'll be in a situation perhaps where we're essentially diverting resources and moral attention from agents, humans and animals who are actually conscious, and essentially kind of like misdirecting resources. Now, this also, that kind of discussion also rests on some hidden assumption, which is that we assume consciousness comes along with some kind of moral responsibility. So if we think something is conscious, then we have a moral responsibility to that system. And that's, I think, an intuition that a lot of people share, but it's also one that philosophers sometimes debate. Like, is it enough just to be a conscious system, or do you need to have strong conscious valence? Like, do you need to have the potential for suffering and so on? So I think that's a whole other area of discussion. But as a more general point, as society begins to attribute conscious experience to artificial systems, I think we are going to need to grapple with some pretty serious ethical issues.
What do we know about how we determine if something is conscious or not? When you're thinking, I don't know whether this fits into the workspace and higher order theory concepts, but when you think about the sort of question of, well, we might interact with them as if we think they're conscious, right? And how do we make that determination about whether it's conscious or not? And also, might there be signifiers that we put into these products to be able to to signify that they aren't conscious, to be able to sort of flag that this is Minnie Mouse, not an actual mouse, like I'm just curious how we make that observational conclusion that something is conscious.
How do we as humans?
Like what? Like I'm just curious. Has anyone ever tested? Like, how do we know?
So there's a whole field of robotics that is looking at like what gets us to anthropomorphize robots and what's the influence of different ways of presenting embodied robots. There's actually less on disembodied systems like large language models and so on. So a postdoc in my group, Clara Colombato, recently ran an experiment. We've got a preprint on this online. It's under review at the moment, where we just asked that question. We realized that no one really asked this of the general public. Like, first of all, have you heard of ChatGPT? So we use ChatGPT as the most well-known example. And we gave subjects a little description of what it is. And then we also gave them descriptions of phenomenal experience. So we said, humans have this subjective experience of the world, and this contrasts against other devices like a toaster. I think that was one of the examples. Anyway, we borrowed language from previous studies that philosophers had run on people's understanding of experience. And so you essentially give people a little prompt so they hopefully know what we're talking about when we talk about experience. And then we asked people very simply to fill out a questionnaire about, do you think ChatGPT has conscious experience and how much? And then also, do you think it has all these other mental state attributes, intelligence, knowledge, communication, capacity for pain, for regret, I think there was about 70 different mental state words. And then we applied a dimensionality reduction technique to those data. We found that there were essentially two principal components there. One, tracking conscious experience, correlated very well with this experience dimension, and the other tracking what we might call intelligence, like the ability to know things and to communicate things and so on. And what we found is that essentially we found two things. One is, perhaps unsurprisingly, people thought ChatGPT was much more of an intelligent agent than an experiencing agent. However, there was a small but non-negligible proportion of the population who attributed significant phenomenal experience to ChatGPT. So 1/3 of the population said it has zero phenomenal experience, but 2/3 said it had some. And I think around 20% of people said it had phenomenal experience approaching that of humans. And what was fascinating was that attribution of experience correlated with how much you use it. So the more you used it, the more you were likely to attribute some level of conscious experience to it. Now, obviously, we can't disentangle causality there. It might be that you tend to use it because you think it's conscious, right? Rather than you starting to think it's conscious because you're using it. But we were pretty surprised by that data. So I think if I were having to bet initially, I would have thought many more people would have essentially been right down at the bottom end, just saying this is just like a pocket calculator. But there were many more people than I expected who were starting to say it had some kind of conscious experience. So this leads to then all these other questions that you might have about, like, what are the characteristics of the person using it that might drive that kind of attribution? What are the characteristics of the system? You know, perhaps certain ways of presenting information, certain ways of responding to prompts. So all of these are really nice empirical research questions that we can start doing experiments on. And Clara is continuing to do interesting work on this. So I think the answer to your question, Dave, is that we don't really know at the moment. We know that there's some kind of level of attribution out there that we can quantify. But then I think this raises all these interesting questions about how that impacts on your moral judgments, on your user experience, your attitudes towards artificial intelligence more generally. Is this something you're then afraid of because you think it's conscious? There's loads of fascinating questions for psychologists to get their teeth into.
Oh yeah, when you think that there's this model that a lot of people have of us as the pinnacle of intelligence, if you like, and everything leads up to us, right? And everything, or even consciousness leads up to us, so we can mistreat animals because they're lower down the tree, or and if we have this perception that AI is somehow above us, does that even change how we think about our responsibilities to them or the way that we deal with it? When we watch people respond to ChatGPT, certainly there is something about the person themselves, like an emotional, expressive engagement that delights someone. Has a totally different experience than someone who's just using it for just a quick kind of in and out answer, and you would expect that more emotional engagement, that more intimate engagement, is going to have a different. It's going to have a different outcome for that person over time.
Yeah. I mean, my colleague at Cambridge, Henry Shevlin, philosopher working on these issues about the future of intelligence, and he gave a lovely talk recently at a workshop we organised on these issues, and he was pointing out that it's possible, I think he's right about this, that essentially all the stuff we were talking about at the start of this podcast about how do you ever determine the intrinsic nature of consciousness in an artificial system? Like, is there a research program which you could do neuroscience in humans and eventually figure it out? He was suggesting that, that's interesting academically, but it might be that society just moves on, and that in 50 years' time, we're just used to assuming these things are conscious, and that there's no real facts of the matter left. People might debate it in journals, but essentially society might move to a position where this is just the assumption. All right. So, and I think that is then a really interesting question about, how does that then intersect with what companies might be doing now? I think you mentioned, Dave, like, would that then lead you to somehow try and steer people's inferences towards thinking it's unconscious, for instance? And it just reminds me a bit of like when my son is 4, and when we have conversations with him about Santa, like, we often try and very like clearly demarcate all the fake Santas that we see when we're walking around town, to make sure that this is not going to like screw up his head when he thinks about the real Santa. So is there a need for, AI companies to essentially like demarcate all the fake ones, so that when they eventually do build the real thing, we'll know about it. So I think there's really interesting questions to be answered. I don't know what the right answer is. It's
such a crazy paradox though, because and all of the surveys that I pretty much ever run on this that I've ever seen, people want to know when they're talking to an AI. They really want to know that, and they want to. And implicit in that is not. I think implicit in that is that there's a transparency, a command control. Whether it is, I want to know it's conscious or not. No, those questions have never come up. But I wouldn't be surprised if there's some sort of implicit binding there that it's like, I want to know it's also unconscious. But then at the same time, people's reactions and wanting to feel this intimacy, wanting to feel good about that interaction, using Pi and feeling better about yourself as a result of having used these tools. That paradox sort of exists there. You want a little bit of both. You want to know that it's not conscious and it's an AI, but you also want to know that feeling of connection and sort of consciousness when you want it as opposed to when you don't. There's a pick and choose aspect there. I know we're at time.
Yeah, thank you so much for joining us again. I mean, this has been a wonderful conversation, and let's do it again soon.
Yeah, absolutely. Well, thanks for having me on. It's been great fun. Absolutely. No, it's been really, really fun topic. So I'd be glad to chat again.
Solid state.